Good day guys, this is your data engineer. Today we'll be doing graphs, particularly parabola and straight line functions. So this is the grade 12 exam question. Let's get on with it. The sketch shows the graph of f of x and g of x. The graph f intersects x at point A and also at B. F and g intersect each other at D and B. The coordinates of f is 2 and k, so everything is here on the diagram as in the description. So the first question is determine the length of AB. So here is A and then here is B. The first thing we must get the coordinates of B, which is the other x-intercept, and then we'll get the length of AB. You realize that the graph of G is 2x minus 6, so that's g of x. So in order to get the coordinates of B, we'll say y is 0, so that will be 2x minus 6 is 0, that's 2x is 6, x is 3, so that's the x coordinates of B is 3 and then and 0. So that means length AB will be 3 plus 1. So that will be the length AB is equal to 3 plus 1, that's 4 units. The question 2 says determine the coordinates of D, the turning point of F. So here is D. Okay, remember that the graph of the parabola or the equation of the parabola is f of x is equal to ax minus 1 squared plus q. That's the equation. So in order to get the coordinates of D, we know this is the x coordinate of the turning point. The x coordinate is 1, and then q, that's what you need to identify. So q is also going through the straight line function. So I'll write here 2.1.2 using the straight line function. That means y will be q, x will be 1. That will be the x coordinate. So that's 2 times 1 minus 6. So q is 2 minus 6, which is minus 4. So that means the coordinate of D is 1 and minus 4. Yeah, so that one is sorted out. Then let's look at the following question. Show that the equation of f can be written as x squared minus 2x minus 3 using the equation here, using this equation. Okay, first of all, going back up onto our graph. Okay, I'll write 2.1.3 over here. First of all, we've identified the value of q. So we can rewrite all of this function of f of x as a x minus 1 squared plus q, which is minus 4. Now we need to get a. That's the unknown that we do not have. So we'll use point A to get small letter a. So point A, the y is 0, the x is minus 1. So I'll replace y by 0 and then x by minus 1. Then minus 1 squared plus minus 4. And then minus 4 will come this side. It will be positive 4 when it comes this on the left hand side. So a minus 2 squared. So 4 is equal to 4a. So divide by 4, divide by 4, then a is 1. So now that I know that a is 1, I can rewrite the function of f of x as 1, x minus 1 squared minus 4. So that's x squared minus 2x plus 1 minus 4. So that's x squared minus 2x minus 3. So that's what the question was asking us. I believe we have proven this same expression here. Then 2.1.4, determine the value of k if f is the reflection of E with respect to the axis of symmetry for f. So which they're basically giving us the information that E is the mirror image of f about the vertical axis. So since we know the equation for f of x in this format, we can conclude that the coordinates of E is 0 and -3. So since E and F are the mirror images, that means K is also going to be -3. So 2.1.4, I'll just say here K is -3. That is it. As short as that. Let's go to question 5. Determine the equation of the inverse of G. Okay. We already know the function of G, so the inverse shouldn't be an issue. You first have to write the function of G of x in terms of y is equal to 2x minus 6. Then when you get the inverse, you have to flip x and y around. So instead of y, you put x, then instead of x, you put y, and then thereon you'll solve for y. So 6 will come this side as positive, equals to 2y. Then you divide by 2, all the terms. Then you find that the equation is going to be y is equal to 1 over 2x plus 6 divided by 2 is 3. Or if you like, you can just write this in terms of inverse of G of x. So if you like this video, please hit the like button and consider subscribing.